29/1/2024 morning shift, the students memory based questions that I am going to discuss. The first question, it is a very easy one, that is D block compound. Which of the following pair will be formed by the decomposition of the KMnO4? It is straight away memory based question. Okay. How the KMnO4 at 513 kelvins it decomposes to give K2MnO4 and MnO2 and oxygen. That is the 2KMnO4, it dissociates to give K2MnO4. The color of the KMnO4 is purple, it is due to the charge transfer. K2MnO4 and MnO2, which is used in the laboratory, that is pyrolusite, and oxygen is formed. Okay. The options that are being given, which pair? The first option is MnO4 and MnO4 minus and MnO2. This is the first option. Second option is the K2MnO4 and MnO2 is given. And third option, KMnO4 and MnO2 is given. Okay. And fourth option, you have MnO2 and H2O. Okay. Correct option is, since KMnO4 on heating gives K2MnO4 and MnO2, therefore first option is the correct option. The second question, it is organic chemistry question. The interaction between pi bond and lone pair on adjacent atoms. The options given as, first one resonance, second one is hyperconjugation, and third one is inductive effect, and fourth one is electronic effect. Okay. This is a simple question. If you know the concept very well in the organic chemistry, automatically you can answer this one, because the interaction takes place between bond pair and lone pair on adjacent atoms. That is, whenever a pi bond is involved, automatically that is related to the resonance. Therefore, the correct option is the first option, because the example here is CH2 double bond CH and Cl. Here, this is lone pair and this is pi bond, and as well as lone pair. These are in conjugation. Then they give rise to the resonance structures. Thus these are the example. Okay. Now, therefore, the lone pair and pi bond interact with each other when they are being related like this. Okay. This is about the organic concept. Next question. Next two questions are on the periodic table. The question here is the assertion and reason question. Assertion is electron negativity increases across the period. Okay, that is the assertion. Electron negativity increases across the period. Okay. Next, what is the reason behind it? The reason is, what they have given is effective increase in the nuclear charge and it is more than the effective shielding. Okay? If you look at the explanation, that is the reason, and why the electron negativity increases across the period. As we move from left to right in a period, as the atomic number increases, automatically the electrons enter into the same energy level, and also the nuclear charge, that is, as the number of protons increases, the effective nuclear charge increases, which dominates the shielding. Therefore, automatically electron negativity increases. Therefore, what is the option? Both statements, assertion and reason, are correct. Okay, reason is correct explanation for the assertion. Okay, this is about the fundamental periodic. This statement 1 and statement 2 is given. The statement 1 is, this is the statement 1, and electron negativity increases, okay, down the group in group 14. They specifically asked about the group 14. And what is the statement 2 that they have given is, group 14 contain metals. Okay, group 14 contain metals, non-metals and metalloids. Now, if you observe the 14th group elements, okay, carbon, silicon, germanium, tin and lead. Carbon is non-metal, silicon is metalloid and germanium is a metalloid, tin and lead are metals. Therefore, it includes the non-metals, metals and metalloids. The statement 2 is correct, perfect correct. But if you look at the electron negativity, what happens to the electron negativity? It will be highest for the carbon and the next elements, they are nearly same. But here electron negativity increases. It may not be true for any group. Therefore, the statement 1 is incorrect and statement 2 is correct. Next question is about the catalysts. Okay, here are the question, and which is the correct match or incorrect match, like that they might have asked. What is the main thing? Ziegler-Natta catalyst. Ziegler-Natta catalyst is used in the polymerization of the alkenes or polymerization of ethylene especially. Ziegler-Natta catalyst, what it is? It is titanium tetrachloride and trialkyl aluminum. That is the catalyst. But here Ziegler-Natta catalyst, where it has to be matched, okay, it has to be matched with titanium. Okay, only metals are being asked. Blood pigment. What the blood pigment consists of? It is hemoglobin. Hemoglobin consists of iron. Next, Wilkinson's catalyst. Wilkinson catalyst is also used for alkenes, and Wilkinson catalyst is the triphenyl phosphine chloride rhodium complex. Therefore, it is matched with the rhodium. Rhodium is the central metal atom. Next, vitamin B12, what it contains? Cyanocobalamin, it is vitamin B12. Therefore, cobalt is the metal that is being present. These are being matched with the metals only, they haven't asked anything. Okay, only metals you have to pick up. Okay, this is how you can match with the others if you memorize the catalyst. Okay, in every shift they are asking about the memory based question a lot regarding the D and F block elements especially. Okay, question. appearance of red color on treatment with sodium fusion extract of organic compound with FeSO4 in the presence of concentrated H2SO4 indicate elements. The first option they have given is nitrogen, second option bromine, third option sulfur, and fourth option nitrogen and sulfur. Especially this is, you might remember about these things, that is sodium fusion extract, it comes under Lezine test, isn't it? Here in the organic compound, carbon is certainly present, but when nitrogen and sulfur are present, automatically, so in the sodium fusion extract you will get sodium thiocyanate, NaSCN. Okay? When it is being treated with FeSO4 in the presence of concentrated H2SO4, FeSO4 oxidizes to give the Fe3 plus. This reacts with thiocyanate, Fe3 plus reacts with thiocyanate, okay, and it gives the FeSCN thrice. Okay. This is how to detect nitrogen and sulfur along with the carbon by means of Lezine test, by taking sodium fusion extract and treated with FeSO4 in the presence of H2SO4. Okay. Next question, chlorine shows disproportionation in alkaline medium. Okay. In the alkaline medium, chlorine or bromine or iodine, especially they undergo disproportionation. Not only that, phosphorus, sulfur, they also undergo disproportionation reaction. But here specifically they have asked you about the disproportionation of the chlorine. They have given the balanced equation, but they show about the stoichiometric coefficients in the balanced equation as A, B and C and D. Okay. This is the balanced equation that is being given. Chlorine, A moles of chlorine, B moles of OH minus, okay, gives rise to C moles of ClO minus and ClO minus plus D moles of Cl minus, okay, plus H2. Okay. This is a disproportionation reaction. Therefore, it is that is chlorine undergo disproportionation or any halogen undergo disproportionation in the presence of alkaline medium in cold as well as hot conditions. Cold dilute condition, it will increase its oxidation state as well as decrease its oxidation state, and whereas in the hot concentrated solution, the chlorine, it disproportionate to give ClO3 minus and Cl minus plus H2O. Okay. If you balance the equation, the balanced equation is Cl2 plus 2OH minus, this is the balanced equation, then ClO minus and Cl minus plus H2O. This is the balanced equation. And what are the stoichiometric coefficients? A is equal to 1 and B is equal to 2 and C is equal to 1 and D is equal to 1. Therefore, the options you might have got 1, 2, 1, 1. Okay? This is the option if it is cold dilute. If it is, because it is not being given, therefore I am not discussing. But if the hot concentrated NaOH is given, then what should be the options? Okay, these are the options, that is 3Cl2 6OH minus, ClO3 minus plus 5Cl minus plus 3H2O. Okay, this is the, then the options will be 3, 6 and 1 and 5. Okay, if it is hot concentrated, then it is 3, 6, 1 and 5. If it is cold dilute, then it is 1, 2, 1, 1. And you know how to balance the equation. There is a shortcut method, or you can use oxidation number method, or you substitute the stoichiometric coefficient in the equation and the relevant equation and try whether balanced or not. atomic structure actually. The correct set of 4 quantum numbers of valence electrons of rubidium. Rubidium is an alkali metal. Okay. What is the valence electron? The valence electron is present in 5s sublevel. Therefore, rubidium outermost configuration is 5s1. Okay. Then correct set of 4 quantum numbers. In the options they might have given different one. If you look at the configuration, then you are able to recollect what is the principal quantum number. Here the electron is present in the 5s sublevel, therefore n is equal to 5, and for s L is equal to 0 and m is equal to 0. Okay. S will be plus half. Okay. The correct set of 4 quantum numbers of the valence electron, S is equal to plus half. If you have seen about these 4 options, then automatically that option is absolutely correct. It is from biomolecules. Type of amino acids obtained on hydrolysis of proteins. Okay, in a very shift they are asking about the biomolecules, whether in DNA or nucleotides or carbohydrates. Okay, students should aware about these things. Okay, then proteins when they are being hydrolyzed, automatically they give rise to which acids? Those are alpha amino acids. There are 20 amino acids, of them 10 are essential amino acids. Therefore, the options that they have given: alpha amino acids, beta amino acids, alpha amino acids, beta amino acids, and gamma amino acids, and theta amino acids. Then right option is the first option. Carbonyl, CO, not carbonyl, carbon monoxide forms a bridge between metal atoms. Okay. The options that they have given is, the first option is triosmium dodecacarbonyl. Okay. Next, CO2 CO8. Next, Ru3 CO8. Fourth option, Mn2 CO10. Okay. Then the right option is, if you know about the carbonyls, then you can easily remember which carbonyl is the one which in which bridged carbon dioxide will, carbon monoxide is there. Okay. Here that is a second option. The structure of this one is CO bonded to CO and 3 carbon monoxides, they are being attached to the each cobalt, and these cobalt not only joined by one bond but also by means of C double bond. Okay, this is the option, the second option. But in the case of the triosmium dodecacarbonyl and ruthenium, also these two, you can see the osmium. Okay, it is related to one another, and each osmium is bonded to carbon monoxide like this. Okay, and if you remember it, most of the questions are being memory based here. Okay, therefore you have to memorize all this. Same thing will be there in the ruthenium also. In the Mn2 CO8, actually it should be CO8. Then each manganese is bonded to the, here not, here is 8. Okay. Then each manganese is bonded to 4 carbon monoxide. Therefore, these 1, 3 and 4, they are not the correct options. Only the second one is the correct option. The physical chemistry, that too very fundamental question. And calculate the molarity of solution having a density 1.25 gram per ml, and what is mass percentage of solute is given as 31.4% H2SO4 solution. Actually, it is a student memory only. It is molarity of H2SO4 solution whose density is 1.25 grams per ml and of mass percentage 31.4. Then straight away you can calculate. If you memorize the formula, then you can calculate the molarity, or you can move to the conceptual way, that is percentage by mass or percentage by weight into 10 into density by molecular weight of H2SO4, gram molecular weight of H2SO4. Okay, if you substitute the things, percentage, how much it is, 31.4% into 10 into what is the density that is being given, 1.25 by 98. Automatically how much you get? You get 4.005. Therefore, 4 is the answer. Okay, but you can calculate in a conceptual way, because the 31.4% means 31.4 grams of H2SO4 is present in 100 grams of the solution. Therefore, 100 grams of the solution, you can calculate the volume of the solution. Then volume is nothing but the mass by density. Okay. You can calculate in a conceptual way by calculating the volume of the solution, which is what is the mass, mass percentage, that is 31.4%, which indicates that 100 grams of the solution contains 31.4 grams of H2SO4. In 100 grams, from 100 grams, what is the volume of the solution? Okay, then mass by density, from that volume of the solution is being calculated, that is 100 by 1.25, you will get the volume of the solution in milliliters. You convert it into liters. Then what is the molarity? Molarity is number of moles by volume, isn't it? What is number of moles? Because 31.4 grams that is present in 100 grams of the solution. Therefore, 31.4 by 98 is the number of moles. 31.4 by 98 by 1000, you can convert it into volume in liters. Okay, then it will be 100 by 1.25 by 1000. Okay, then you can get 4.005 only. Among the heterocyclic compound that contains sulfur atom, this is a straight one. Okay, what are the things that are being given? First option here is pyridazine. Okay. Second option that they have given is furan. Okay. Third one is thiophene. Automatically you can remember, whenever I say thiophene, automatically you can remember thio is the word that is used for sulfur atom. Therefore, that is the option, pyrrole. Therefore, option is the correct one. Then if you want to have a look over what are the types of molecules, furan, we know that it is a heterocyclic compound which is aromatic in nature. This is the furan. You might have heard it in carbohydrates also. Then pyrrole is a compound, heterocyclic compound which is also aromatic. Okay. Then pyridazine. Pyridazine is the one in which nitrogen atom is present here. Okay. Therefore, thiophene contains a sulfur atom. It is, if oxygen atom in the furan is replaced with sulfur atom, then you get thiophene. Okay. From the electrochemistry, find the weight of zinc in zinc sulfate electrolysis when 0.015 amperes of current passed through the electrolyte for 15 minutes. Okay, you have to find out the weight of zinc. You can, if you memorize the formula, then it is quite okay, because mass of the substance can be calculated by means of the molecular or atomic weight of an element into current into time by Z into F. Okay, from this formula you can calculate the mass of zinc here. What is the atomic mass of zinc is 65.3 into current 0.015 amperes they have given. Time you have to get it into the seconds, that is 15 into 60. 15 minutes they have given, therefore 15 into 60. Then valency of the metal, that is Z, that is equal to 2 into F is 96,500 coulombs. Okay, straight away you can calculate, or from the 96,500 coulombs when passed through the electrolyte, the weight of metal that is deposited is equal to equivalent weight of the metal. That is equivalent weight of the metal. Zinc is 65.3 by 2. I can once again recorrect it as 65.3 by 2. Okay, then you calculate the quantity of electricity by multiplying the current into time. You will get the coulombs. Okay, then 96,500, 65.3 by 2, then 0.015 into 15 into 60, how much? Then you can get the same answer. Okay, this is 0.0046 grams. This is the correct option. That number of species in which bond order is 1 and is paramagnetic. Okay, that is the question. Then what are the question species that are being given? He2 plus and another one O2 plus and O2 2 minus and N2 plus. What are the number of electrons present in it? Here 3 electrons are present in He2 plus and O2 plus 15 electrons, O2 2 minus 18 electrons, and here that is 13 electrons are present. Then what are the bond orders? Bond order and magnetic nature. As total electrons are odd in number, automatically they are paramagnetic in nature, except paramagnetic in nature. And next, the bond order here, that is, in this case it is 0.5, it is 2.5, and O2 minus, it is having, that is O2 2 minus, it is having 1 bond order, but this 13 is having the 2.5. Now, what is the magnetic nature? Regarding the magnetic nature concern, all these odd number electrons, they are paramagnetic in nature, but O2 2 minus is only one which is diamagnetic. But here, what is the question? The bond order is 1 and paramagnetic. There is no species here in which possess bond order 1 and paramagnetic. Therefore, that is 0. If it in integer question, it is 0. Number of compounds that gives positive feeling test. Okay, benzaldehyde, acetophenone, methanol. Okay, feeling solution, Tollens reagent solution, Benedict test, and Schiff's reagent. Especially these are being test used to distinguish the aldehyde and ketones. But In the options, only one ketone is given, benzaldehyde, acetophenone, methanol. But which gives positive feeling test? Here is very tricky, that you have to memorize it. Okay? In the conceptual things, the aliphatic aldehyde group and aromatic aldehyde group and ketones, if you want to differentiate these things, aromatic aldehydes and ketones do not give positive test for the feeling solution. Therefore, what is the aromatic aldehyde? Benzaldehyde is this one, benzaldehyde. Okay? Then the acetophenone also contain, it is a ketone as well as it contains aromatic ring. Next, the methanol. What is the methanol? Methanol is nothing but formaldehyde. Only this answers the feeling solution test. These two doesn't. Therefore, what is the option here? Only one, that is, if it is an integer, then only one compound answers the test. Which of the following is incorrect? It is a thermodynamics question. It is incorrect. Incorrect statement. The first one, delta G is equals to 0 for reversible reaction. Okay? For reversible reactions. Second one, delta G is less than 0 for spontaneous reaction. First I will write the options, later on we will discuss about these things. Third, delta G is greater than 0 for spontaneous reaction. Probably, if you know the concepts well, probably you got the answer also. Okay, for spontaneous reaction. Such a simple questions they are giving. Delta G is less than 0 for non-spontaneous reactions. Then straight away you can know, this is the conceptual thing. Gibbs free energy is the amount of energy whose decrease in value is able to do the work for non-expansion, or it is used to convert the reactants into products. Okay? Then delta G should be less than 0 for spontaneous reaction. Therefore, this is the correct one. Delta G less than 0 for the spontaneous, non-spontaneous process that they have given. Okay? Incorrect statement if they have asked, then delta G is equals to 0 for reversible reaction, delta G is less than 0, for the spontaneous, that is the correct one. These two are correct statements. Now, if they have given delta G less than 0, then for non-spontaneous process, okay, then it would be wrong. Only the third option, probably they have given, I recorrected, delta G is greater than 0 for spontaneous process. This is the option that they have given. Okay? Then, therefore, the third option is the correct one. Delta G is less than 0 for spontaneous, not greater than 0. Next question is from organic chemistry. You have to look over that one. That is, this is the reaction. CH double bond CH2 is given here and ether group is given here. Okay? They have given concentrated HBr excess. Okay? Then what is the product that is being formed? HBr, whenever ether is there, it divides this as H and Pr. And what about here? Here addition takes place after the ether reaction or after the alkene reaction, the ether reacts. Okay, HBr. Then it is following the Markovnikov rule. The hydrogen will be added to the carbon, to that carbon where it is more, it contains more hydrogen, so that it can form the stable carbocation. Therefore, the major product here is this option, that is OH, it should be there, and here you have CHBr, CH3. This might have been option for that question. Organic chemistry, conversion based, and here cyclohexene is given and chlorine. There are two parallel reactions that they have given. One is sunlight presence and another is CCl4. Then automatically sunlight presence, it always a free radical substitution. Therefore, allylic substitution takes place. Therefore, this might be the product. And another, in the presence of CCl4, chlorine addition takes place. Therefore, chlorine addition. These two should be the options here. And also, if it is because it is anti-addition, therefore you can make it as like this also. If okay, product P of the following. Okay, find product P of the following. This is the reactant. It is, the first reaction is H2OH plus, then automatically water addition in the presence of acidic medium. Second one, CrO3, that is oxidation. And third one, that is NH2, NH2. Okay, KOH. They have given KOH in ethylene glycol. Okay, what are the products that are being formed? First, water addition. Water addition according to Markovnikov rule. H2O addition according to Markovnikov rule. Then this is the first reaction, OH, CH3. Next one is oxidation, CrO3. Okay, just a simple reactions that there won't be any twist in this one. Next one, that is ketone is being formed, and they have given Wolff-Kishner reduction here, NH2, NH2 and KOH, alcoholic. Then automatically the C double bond O changes to CH2. Therefore, this is the product that is being formed. This is ethyl benzene. Therefore, the product, final product is ethyl benzene. Okay, that is there in the option.